In this example, we have x divided by y squared plus 1 divided by y, all divided by y divided by x squared plus 1 divided by x. So here we have what I would say a really super complex fraction. We have lots of fractions in this problem. So we have 1, 2, 3, 4, and then the big fraction. So there are 5 fractions here. There's definitely a lot we can do here to simplify, and the way that we want to think about this is really in parts. So what I want to do is I actually want to just focus on my numerator first and simplify that. Then I'm going to focus on the denominator and simplify that, and then I'll worry about simplifying the entire fraction. So we're going to split this up into pieces. So the very first thing that I'm going to do is just focus on the numerator. So my numerator says x divided by y squared plus 1 divided by y. So if I wanted to simplify these fractions, I could just add them. But we know that to add fractions, we need to have common denominators. So my LCD for just these two denominators, remember, I'm completely ignoring this denominator for now, just y squared and y would be y squared. So let's go ahead and fix the fractions that need to be fixed. Now in this first fraction, my LCD already matches. So this one's good just the way it is. In the second denominator, I have just y, and I need it to be y squared. So if I multiply by y in both the numerator and denominator, I'll get exactly what I need. So now I have x over y squared plus 1 times y is just y, and y times y is y squared. So now I have common denominators, and I can go ahead and simplify that. X plus y is just x plus y, and all of that goes over y squared. Now be careful not to cancel any of these out, or else you're going to be back at square one. Okay? So instead of having 2 fractions in the numerator, now I have 1 fraction. So let's go ahead and simplify the denominator as well. So the denominator is y over x squared plus 1 over x. So again, what I can do to simplify is I can actually add these. So I'm going to find an LCD because right now they don't have a common denominator. So the common denominator for x squared and x is x squared. So once again, you see that the first fraction already has that denominator. The second one doesn't. So to make an x squared, I just need to multiply by x. If I do it to the denominator, I have to do it to the numerator. So now we have y over x squared plus 1 times x is x, x times x is x squared. So now, because I have common denominators, I can go ahead and add my numerators. So I have y plus x, and the denominator is x squared. So what I'm going to do now is I'm going to rewrite the original problem. I know that my numerator that used to look like this can actually just be written as x plus y over y squared. So x plus y over y squared. And what used to be this complex denominator, now can be rewritten like this. So I have y plus x all over x squared. And now we can rewrite this just like we did in the previous example. So what I'm going to do is I'm going to write the numerator. And then instead of writing divided by as a line, I'm going to write it using the division symbol. And that's being divided by y plus x over x squared. Now we know that this can be rewritten as multiplication. So I'm going to keep my first fraction the same. X plus y over y squared. Instead of division, I'm going to make that multiplication. So because of that, I have to reciprocate the second fraction. So that will become x squared over y plus x. Now, let's go ahead and see if we can cross out any like terms, or any terms that will cancel out to equal 1. So again, be careful not to do things like x squared divided by x. You have to remember that these binomials are in parentheses, so we want to keep them together. Alright, so we can see that we can't divide this x squared by x, but instead, if you notice, here we have an x plus y. And although this one isn't in the same order, we know because of the commutative property that y plus x is the same thing as x plus y. So those two actually cancel out. And what we're left with in the numerator is just an x squared. And all that's left in the denominator is y squared. And those can't simplify because the variables are different. So that is our final answer. So again, just like the previous problem, our final answer is just a simplified version of the original problem. Again, if you wanted to choose an x and y value and plug the same ones into the original problem and into our simplified problem, you would find that they do actually give you the same exact value.